Okay, so P15.4 part 2, the electric motor, and this is basically a very clever application of Fleming's left-hand rule that we saw last lesson. So basically, if you imagine you have got an arm of wire like this, it's the easiest way to think about it. Okay, so that's my wire. And let's say that I send a current through that wire, and my current is going around this way. Okay, so it comes in here, goes around here, and then goes out again. So I know the direction of my current. Now let's say that I put that in a magnetic field. So let's say north there, and a south here. Okay, so that's my so I've now got a coil in a magnetic field. So you know which direction your magnetic field is going to be going in. Your magnetic field is always going to be going from north to south. So that's going to be like that. I know which direction my current is going in. Let's go in this way. These two, as you can see, are at right angles to each other. So then I need to know is, does this arm move up or does this arm move up? So if you look, so okay, let's start with this one because it's easiest for my fingers. I know that that one is going to be going downwards because my thumb is pointing downwards when I do that. So this one is going to go down. Now this is the really clever bit about this one. As you can see, because I've got this in a loop like this, and I'm putting not just a wire through it, but I'm putting a loop through, this side gets a force acting downwards, this one gets motion acting downwards, and this one, because it's got the current going in the opposite direction, it is going to have, there we go, thumbs now going upwards, so it's going to have motion in the upwards direction. So if you imagine that so what I've got here is I've got an arm, so this is from a side-on view now. This force has got a force acting that way, that one's got a force acting that way. And it's got a pivot there effectively. But what it's going to do, it's going to spin round, isn't it? It's going to spin round really fast, and that's what motors do, that's the whole point of them. You turn in electricity into motion, that's what a motor is. And it's rotary motion, it's rotating. So, now, here's the thing, right? If it rotated round like this, then this current would end up on this side, and it gets stuck, because this side always wants to be pushing upwards to keep it spinning in a circle, and this side always wants to be pushing downwards to keep this side spinning in a circle. Which means that the current always needs to be going this way on this side and this way on this side. So what you have is, you have something called a split ring communicator here. And what that does is, and then you have graphite brushes here. And the reason why they're graphite brushes is so that it can move freely without getting stuck. So that's graphite brushes, and this is your split ring. So every time this turns through 180 degrees, the side that is positive, so let's say that this side starts out as positive, so this side is the positive side and this side is the negative side, then what's going to happen is that every 180 degrees, then this arm will become negative and this arm will become positive, so then the current will go in the opposite direction for this arm. So it turns 180 degrees, which means it gets over to the north side. It then goes on to the negative side, so that means that it now gets the current going in this direction. So that's the handy bit. It means that the idea behind this is it means that always the current is going this way for this side and this side for this way, because every 180 degrees it turns over which one's positive and which one's the negative, so it never goes past this point, which would cause it to stop. If that wasn't there, it would be turning this way, and then this current here would have a force going upwards and it'd say nope, stop. So that's why you need that split ring. And the brushes are just so that you've got something where it can actually move and maintain an electrical contact.